Hey there, welcome back to the channel. My name is Chris, and today I'm going to do a little bit of 3D modeling. Also going to do a little bit of printing, but that isn't all that interesting, so we'll focus on the modeling. Really what I want to show is how I look at the problem, how I approach it, and how I design the thing from the problem that I'm looking at. So let's go take a look at what I built first, and then we'll go backward and look at how I designed it. I'm working on building an automated test rig to allow me to test software and drivers for embedded devices, so you actually need to have hardware that you can test on. When all of this runs, I'd like to have some indicator of whether things are in the process of running, have failed a test, or have succeeded. And so what I wanted to do was just add some lamps, which is what I've got here. I also have a button that I can push to automatically start all of the tests. So let's go take a look at how we got to this point. I'm working on building an automated test rig for Meadow to, as the name implies, automatically test things. So the idea is when we do a check-in, this will pull code and build for us. I'll cover how all of that works in a future video. Really what I'm interested in today is having some way to give a notification that things are done, a visual notification. I could use this display, but this is a device under test, so this is not the appropriate place to do that. So what I'm going to do is I'm going to add some lamps to this. So I've got these 22 millimeter lamps. You can see that this is a 24 volt, and I've got 3 different colors. So test succeeded, test failed, and in process. Then I'm also going to add a push button here that you can use to manually trigger the tests just by walking up and pushing a button. This will use a normally open switch, so that goes on there. I've got normally closed as well. Those are typically red, but I'm going to put all 4 of these on. And I think what I'll do is I'm just going to line them up over on the end here, something like this. And then I'll mount them to this DIN rail. So what I need to do is I need to design and print some mechanism to hold all of these and hook it to the DIN rail. Now, printing something that will hook to DIN rail, that can be done, but it's honestly much easier to just get something like this. This has the spring-loaded latch mechanism, so that can just attach like that. And the way all of these 22 millimeter switches and lamps and things work is it's got this, you basically generate a hole in a top plate. This goes through the hole, locks into this piece that goes below the plate, and you can see this screw here and this screw here. You basically run those in. Those go into the back of whatever the plate is and pushes against this, and that holds it in position. So really I just need a rectangle box with 4 22 millimeter holes for these, and it needs to have a standoff so that it's up high enough that they can fit above this. Then on the bottom it needs some way for me to mount this. This has several mounting options. Probably just use these 3 holes here. And then maybe a little bit of space along the side of it or something for the wiring. So let's go open up Fusion and do some design work. The first thing we need to do is create a new project, and I like to immediately save it to name it. I then like to start by building models of all of the pieces that go inside my box. I don't start with the box itself. I start with the things that go inside of it, even if they're just kind of gross, blocky objects, because it allows me to move those around and see them inside the enclosure. I've tried in the past where I just designed the enclosure straight without doing the pieces that go inside, and it never fits. It never works out right. I always am off by a few millimeters here and there, and I have to iterate several times. I've found that it is much, much faster and more reliable for me to do the things that go inside the box and then design the box around those. So what I'll do is I'm going to design the switch, well, I guess the push button with the switch, and then the lamp. The lamp is real simple. It's pretty close to a cube. I guess we can do this, rectangle body, this rectangle body, and then I don't really need to worry too much about doing 2 circles, but I guess I can. It'll be simple enough. So what I'll do is I start with the largest dimension piece, which is the metal on this. I'll start with a new design just for the lamp. This is a little more challenging. We're going to start with a rectangle as we view it from above, and then we'll trim off the side pieces when we get to that. So that's close enough, I would say. All right, so now we want to actually design our box. So I know some rough dimensions. So first let's create a sketch for it. And we'll do our overall rectangle of the outside of it. So I want it to be 48 because that's the width of this. And I measured the inside of the box, and it is 195 this way. I like to put in center lines. And then I center my sketch at the origin. Now what I'm going to do, I think, is I'm going to make a face plate that the lamps and switch or the button attach to, and then kind of a box that it sits inside of. So really what we'll have is kind of a bowl-shaped box and then just a plate that mounts to the front of it. Remember, the way these work, that screw pushes it against the plate, so the face is against this piece, not here. There's a gasket, so if I have a little bit of space here, that's fine. That's what I'll do, is I'm going to put that there. I want this push button to be centered over the DIN rail so that when I push down on it, it's not trying to wobble. So let me figure out where the center of that is. That's where the DIN rail will sit. All right, so that is sitting right where I want it. Now I'm going to add in some lamps. All right, so now we just have to decide how thick this should be. 4 mil is probably more than adequate. I'm gonna go 3.5. Now we need to create a sketch for the holes. Now I'll create the box that this sits inside of. There are a variety of ways to do this. You could do it so that this fits kind of into an inset or a recess on the box. You can have it flush mount. You can bevel the edges so it kind of fits in with a 45-degree angle. It really depends on kind of the finished look you're after. Since this is just going onto a test harness, I'm just going to go with a box, and this is just going to sit right on the face. There isn't, just going to be flush. It's not going to sit down inside of it. The one thing that you do have to think about is how it is that you want to attach the two pieces. I've done tabs. I've done a lot of different stuff. This one, I'm just going to put some bosses on the box and then drill some holes through this. I'll give pilots for this. When I say drill, I'll do it probably here in CAD to make the holes so that I can run a screw through this into bosses that are on the box. So really I just need a box. It needs to have a flat spot on the underside for this DIN rail clip, and then it has to have holes to mount to it. I probably won't make it solid all the way around or even a solid back. So again, the first thing I'm going to do is I'm going to CAD this part here so that then I can CAD the other part that this attaches to. Now this doesn't have the spot for the DIN rail, but since I'm not actually going to model the DIN itself, I'm not going to worry about putting the groove in here. That gives us enough clearance even with the thickness of the bottom, and I want to have enough space to be able to get wires in here. They will probably stick out at an angle or definitely not straight, so that gives us a little bit of room to play with. So it gives us a place to mount it to the DIN rail. And walls, we need holes at the top and bottom for wires to come out of the wire loom. Now we have our holes for the wire loom. All right, so really all that's left are mounting bosses. The one thing you have to think about here is printing. So I'm going to print it sitting like this. So this will be on the bottom. That means that supports will have to be generated for these wire holes. Probably could have avoided that by doing a circle or something, but I'm not too concerned about it. Again, the finish on this doesn't have to be super awesome because it's just on a test box. We want to basically we could build a pillar that just runs all the way down. If you don't want to run it all the way down, you can create a boss up here and then slope it at, less than 45 degrees or 45 or less down into the wall. So it looks like it'd be a triangle from this side. You can do that so that you don't have to print supports for those. You can see there is not a lot of space in here between the walls and the push button. So it needs to be kind of hard to see because we've got this closed up. It needs to be in between here. That just puts in those pillars. That puts holes in the face. And it puts holes in the pillars for the screws to go into. All right, I think that will do it, at least for version 1. Let's do one quick sanity check. Show all of these. Aha. And that's why we do the sanity check. I'm intersecting up here. That will not work. Works for everything else. So this one is a problem. So what I'm going to do is I'm just going to grab this button and move it. All right, we're not impacting. And if we hide the second body, the hole is in the right spot. All right. Always pays to double, triple check everything before you take it to the printer, because this is not going to be a quick print time because of how big it is. All right, take it over, print it, and I'll be back. In case you're interested, just put it into the slicer, and looks like I can print both of them at the same time, and it will take, oh my god, 10 hours. Yeah, I really need a faster printer. But I can fire this up and let it run and check it in the morning. Looks like it fits here quite nicely. The holes in this, all 3 of them, so those lined up right. These fit in here nicely. Depth-wise, you can see that it's just fine. These fit very nice and snug in here. So really now I just need to actually assemble everything and make sure it all fits together. So that's how these mount. You can see that the pressure of that is already bowing this a little bit, so you don't want to tighten that down too much. In retrospect, I may have made this maybe either a little thicker or added a reinforcing rib around it. Probably would have made it a little bit better. So a raised edge all the way around maybe. But I'm hoping that once I put it on and put some screws on, that'll help pull it against it. Well, that's all set up. Now let's make sure it fits into the case. Looks like I have plenty of space. My main concern was the screws that have to come through here and here, that on the back side there'd be enough room for either the head of it if it's coming downward or the nut if it's going up. But I think we're good. I can even put my finger in here. So it's got enough room for my finger. It definitely has enough room for a fastener. So I'll mount this on it and then we'll go put it in the box. I absolutely should have made this thing about 2 millimeters wider. Looks like it fits pretty well. And I've got it all wired up. I don't have any logic yet running, but I can, manually turn things on. And they all work. If I turn that on, you can see it's real dim. It's because it's got a blue LED back behind it. I've got to order a red. That's all I've got for today. Thanks for watching.